Hello everyone, and welcome back to the fourth video here in this series in our review for inference on means. This video is going to talk about two-sample t-tests. And really what we're going to focus on briefly is just the difference between a one-sample t-test and a two-sample t-test, and even more specifically, how do I differentiate between a two-sample t-test and a matched pairs test. So let's jump right into what we're going to do here and take a look. So again, the biggest difference with two samples, very similar to confidence intervals, I have to make sure that I have two independent samples. If I do not have independent samples, it's not a two-sample test. The second thing is that my assumptions need to be true for both. And the last thing is we have to answer that question of, do we have a pooled variance in this case? Are we assuming that the first population standard deviation is equal to the second one? And again, very similarly to confidence intervals, this is something where you will be told in the problem whether or not this is a reasonable assumption. It's not something that you're going to have to read the context and try and figure out on your own, because it's one of those things where you can make an argument either way. And so that is the biggest difference here. And now again, very important, you want to make sure you use the degrees of freedom that your calculator spits out. The reason for that being is that your p-value is dependent on the degrees of freedom. And so if you end up using the conservative estimate, which is the smaller of the two sample sizes degrees of freedom, your p-value would end up being different than the one your calculator spits out. So make sure you use the calculator degrees of freedom, and that is the one that you write down. So let's take a look at an example problem here and work through it and see how this works. So this question, I'll spare you the whole deal, but it's essentially about a new procedure for ACL repair. And we're comparing the new procedure to the standard procedure or the old procedure, and we're trying to determine, do we have evidence that the new procedure leads to a quicker recovery? And so for my null hypothesis here, I'm going to assume that the mean recovery time for the standard is equal to the mean recovery time for the new. My alternative is going to be that the new one has a shorter recovery time. I'm still going to define these here, right? This is the true mean recovery time of the new procedure. This is the true mean recovery time of the standard. Now, one thing you may also see here, potentially as a side note, sometimes you may see this written as mu sub n minus mu sub s equals 0. They mean the same exact thing. Whether they're equal or it's written as a subtraction statement, you can interpret that the same exact way. If you subtract them and you get 0, it means they were the same number, which means if I was going to rewrite this one, it would just be mu sub n minus mu sub s is less than 0. It literally comes from algebra and subtracting that second mean to the other side. The way that you write these is important, and the reason for that, at least as far as which one is first and which one is second, is it's going to affect what you put in your calculator, because your calculator is always going to take the first one minus the second one to look at your difference here. And so make sure if you write your hypotheses this way, that the new procedure goes in as your first sample and the standard procedure goes in as your second sample. So for my assumptions now, right, so here's my hypotheses. My assumptions. What's important here is that we had random assignment. Right, this says we're randomly assigned. So we have random assignment. Perfect. And both my sample sizes are greater than or equal to 30. As you can see here, one is 110 1 is 100. I'm good to go. My test is a 2-sample t-test. And now to get my numbers, I'm going to go to my calculator here. All right, so I did the new procedure as group 1. So I need to make sure I put that in as my first one. And then your standard deviation here for the new one was 29 versus 34. And then 100 and 110. So when I go to calculate this, one, I need to make sure, right, when I look at this actual thing here, you get a t statistic here of, now depending on how this did this, you should get negative 7.07, which essentially gives me a p-value of 0. Right, this is a p-value that is essentially non-existent, and so I definitely have evidence that the new procedure has a shorter recovery time than the old procedure. That probably wasn't surprising to you, given the fact that when I actually look at the mean difference, it's 31 days difference. It's an entire month reduction with sample sizes that are roughly similar and large. So one thing I always like to do with these questions is I try to anticipate the conclusion before I get there. Looking at the raw numbers, do I think I'm going to have evidence or do I think this is too close? Right? With the example in the 1-sample t-test video, those means were very close together at 12.05 versus 12.1. These ones, not so much. So I hope that was helpful for you to see one example of a 2-sample t-test, and I'll see you guys in the next video.